All right, and we're going to go through inheritance today, class inheritance. And what we experience with class inheritance is just like genetic inheritance. There's going to be a parent and a child, or in computer science terms, there's going to be a base class and then a derived class. So we'll have to remember those terms, base being the parent and derived as, you know, the characteristics and traits that we have inherited from the parent. All right, I'm going to first start here on the whiteboard and talk about what that means. Now, we're going to step through a whole kind of a problem here. It's very simple, very short and sweet, but nonetheless, we'll step through an entire problem so that hopefully this kind of cements and makes sense. So we're going to look at just a person and a student. A person and a student. So here, person is going to be our base class, and then student will be our derived class. And we can kind of see the way the relationship forms is this way, because every student is a person. However, not every person is a student. So that's why we get this one-way relationship, and we get this inheritance going that one way. Now in C++, what inheritance gives us is the ability to now use and leverage any of the public methods and data that is in the base class. So if person here has some public methods, it might have method 1, method 2, method 3, and as long as those are public, well then those will also get passed along here to the student. So now the student will be able to use those methods from the parent. Here's a good example. Let's say that there is a set social security number method as a public method in the person class. Well, that gets inherited. And then with our student object, if we just had a student, let's call it student 1, if we then have that object created, we can actually use the set SSN method from the parent because it's public and it's inherited. So we have suddenly a lot of access, a lot of very powerful access. Now, what's interesting, though, is that it's only public data and methods. It's never anything private. So this student here, over here, the student object we created, could never have access to any of the private data that might have been held over in the person class. Let's say that private data is SSN, and then maybe a name. We could never access directly student1.name because name is a private data element. However, if we had a function inside our person class for get name, like that, well, we could certainly use that instead of going directly into the variable name. We'll just use get name. And again, since that's a public method, then we can do, then we've got full access to it. So that's sort of what we're going for here. Now I'm going to create, and I've already coded it, and we'll look at the code in a second, but I've got a person class here, and private will be those two pieces of data that every person would have, and that's a name and a social security number. And then over here for student, every student will also then have a name and a social security number. But for a student, I'm just going to add one extra private member, and that's going to be a grade point average. So we can see here, clearly every student is going to need a name and a social security number. and they'll also have a GPA, but not every person needs a GPA. Every person just needs a name and social security number. So if that makes sense, it should make sense when you think about just the one-way relationship. Is a relationship. A student is a person, but a person isn't necessarily a student, okay? All right, so when we look at then, at the various methods then, in this case, in my person class, I'm gonna have a print method just because I want to be able to print out the data that a person object might hold. We'll probably need a setter and a getter, depending on what we need to extract. But for right now, we can probably leave it like that. We could easily do a set SSN if we need that. We could do a set name if we need that. We could do a get name if we need that, and then a get SSN. So standard mutators and accessors there. Over on the student side, we'll kind of have the same thing. We'll have a print function because I want to be able to print out the student data as well. And we really don't need horribly much else there over in the student function for us. All right, so that's kind of what we're going for. Let's take a look then at the code and see how all of this sort of gets put together. So let's first go with our person class. I'm gonna minimize that console to way down there. Okay, so here's our person class. This looks very familiar at this point. We've got two private member variables, SSN and name. Here is our default constructor where we're just going to go ahead and put some dummy values in there just to get the object created and sort of intact. The data is worthless because SSN of 0 and a string set to null, is kind of worthless. But the object is going to successfully get created, and it'll it'll exist fine. It just won't mean much. Here, though, is our much better constructor, right? We're going to pass to it the social security number, and we're going to pass to it the name, and then we'll just set those. A print function, nice and easy. We're just going to count the name, and then we'll count the social security number. No issues there. Here's a typical a mutator to set the social security number. Whatever we get as the integer s, we're going to set that to the social security number. And then I do have an extra method here, get name, just because I think we'll probably need that later. I think we might need it later. All right, so there's our person class. Not too difficult to process. This looks a lot like the classes that we've been doing for the last 2 weeks. Let's look at the student class, though. This is going to look way different because we have got inheritance happening. All right. So let's take a look at what those differences then might be. Okay, first of all, the very class header there is going to have that extra field in it, public person. And what this is saying is every public method, or even if there's some public data, it's rare, but if there is some public data, then the student class is going to be able to leverage it or enjoy it or use it. So every student will have now a name and a social security number. Oh, and by the way, we're going to also add just one extra data private member to the student class, just their GPA. All right. So that's fairly straightforward. Let's take a look at these constructors, though. This is where we kind of have to scratch our heads and make sure that we understand what is the flow here and how are these constructors actually working. Okay, so let's look first at the default constructor. The middle stuff is fine. GPA, we'll just set that to 0. Just get some dummy values in there just to get the object stable. But take a look, though, at the constructor header. Student, and then a colon, and then person. And this is saying a student derives from person, or the derived class derives from the base class. Now, what this is actually doing is when we call a student constructor, what we're actually also doing is we're calling the person constructor. This is a function call right here, person with open close parents. That's a function call. So we have to look at that. Well, what is person with an open and close? Well, let's go back to person.h, and here's that method. And it's going to set the SSN to 0 and the name to the null string. So that default constructor is going to happen as soon as we use the student default constructor. It's a matter where both constructors happen at the same time. The student one is going to go ahead and set GPA to 0, while the person one sets social and name to those default values. Okay, so we're good there. We're good there. Now we know that our default constructors are always going to look like our more expanded constructors, just with, we'll have a little more data. Specifically, we're going to have some parameters. And we need to know then, well, how do we pass these parameters to the base class and to the derived class? And that's where this header comes in. So we have sort of this expanded header for this constructor. And that is where we're going to receive these 3 pieces of data when we construct our student. We'll have an int, a float, and a string. Now, interestingly, the only private member data that the student has is GPA. So we're not going to, all we're going to use out of these 3 pieces of data that we send to the student constructor, the only thing we're going to explicitly use here is this float G that I'm going to set to GPA. Then the question is, well, then what happens to the int S that's going to represent social security number and the string N that's going to represent name? Well, those get passed directly to the other person constructor. And this one is going to create a person object and then set the SSN and the string to those values, whatever was passed to it. So this flow here is probably the most critical line of code in our project. Now, a couple of cautions here to be careful with. When you have this flow through constructor here, the secondary constructor that constructs the object in the base class, it's a common mistake to go ahead and do this, int S and string N, but your code will, your IDE will probably complain about that. Xcode, we see right here, Xcode does not like that. And that's because, this is not a prototype. We're actually calling the real constructor. You would only put those, data types in alongside the parameter names if it's a prototype, but here it's not. We're actually just calling it. So let's look then at the flow. If we get S and N constructed here with student, let's go back to person.h now and see, well, what happens here? Here is the expanded constructor with those 2 data elements, S and N, int and a string. And you can see then that those just simply get called and those data elements get populated. So that is probably the most challenging part of this kind of a project to make sure that we wrap our minds around. Now, there's something else that's very interesting. You've probably already picked up on this. It's very interesting because here in my student class, I've got a method that's called print. However, in my person class, I also have a method that's called print. So if I create an object, let's say an object is I'll call it dad. If I called dad.print, well, then the question becomes, which print method do we use? Do we use the print method that belongs to the base class, or do we use the print method that belongs to the derived class? And what we have to do there, if you do have the exact same name for those methods, and I've done that intentionally here, I think normally I would just have discrete names so we just don't have to worry about this. But if you do have two methods of the same name, we've got to tell the compiler, okay, which one do we use, person or student? And in this case, we're going to use the student one. We're going to use the person one to start. Now look at what I did here. I am using this scope operator. The two colons together are the scope operator, and it's telling us, okay, in which scope do we find this print function? And what this is saying is first go to person and do that print. So if we do a print, it'll first go here, it'll print out that data, but then I've got another line here of our GPA private member that's also got to be output, and that's just going to be the next line in the code. So we do sort of two print operations, and yet they're both defined as part of a single print method in the student class. And what we're going to do is first call person.print, then we're going to call, or then we're going to proceed with the code, which is going to then output the GPA. All right, so that's kind of what we're going for here. Let's look at our demo program. It's going to be really, really quite simple. Here I'm starting with, I'm going to create a dad object. This dad constructor, it needs a social security number and a string for the name. So there's my constructor with both of those. Here, I'm kind of putting a little header, information about person, and then I've got get name here in order just to have that sort of table header, you know, a little introduction there. So this is going to be information about person dad. So we've got the dad.get name. Let's take a look at that. Get name. What is that method? Okay, well, let's first go to person. And we see here that the get name method right here is just simply going to return the name. That's fine. Great. We can do that. We'll go back to name here, and we're just going to then call dad.print. It's important to know, you know, since dad is an object of type person, then we're going to go to the person class for that print method, not student. This is a person. All right, and then we get the dad print happening. Let's take a look at the constructor here for a student. All right, the student constructor. Let's take a look at that. The student constructor needed these three elements: an int, a float, and a string. So back here in main, here is our int and our float for GPA and our name. Here we've got kind of the same little output header, information about student, but then I'm going to output now ellen.getName. Now I want to pause here a second. Okay, Ellen is a student object. However, if we go to student.h, I don't see any getName method here. It's not part of the student class. But still, our code works because we've got inheritance happening, and that getName method is getting inherited from the parent to the child. So Ellen is now going to enjoy that public method getName because that's the way inheritance works. And then we've just got then Ellen will print. This time though, since Ellen is a student object, we're going to go to the student.h, to the student class, and use that print method. All right, so let's run this now. I'm going to there's our build, and there we go. There's our output that's just the data dump of these two objects: information about person dad, and then information about student Ellen. And surprisingly, Ellen is my oldest daughter's name, and I literally am a dad. So I guess this whole code is really about, well, it's about me. All right, so that is inheritance in a nutshell. And this is base level inheritance, just strictly one-way flow. We've got a few more things ahead of us in this class about inheritance. One is going to be multi-level inheritance, meaning we can have a base class and then a derived class and then another derived class, sort of a daisy chain of inheritance. And then we'll get into a few more other complex things. We can figure out how to overload some of these things and yeah. All right, so that is the primer on these inheritance classes. I'll stop here now, and I'll also stop the video, and then I'm going to turn this now to questions for everyone if anyone has some.